and welcome to Math with Bill. I'm Bill, and today we're going to be looking at the slope equation. Now, for those of you in Algebra 1 or 2, slope equation can sometimes be one of those really hard things to get a hold of. But I think after this video, we're going to understand a little bit more about slopes and hopefully have a neat way to remember how to find the slope of a line. Great. So our slope, again, just as a quick reminder, is a measure of the steepness. And I put that in quotation marks. Steepness of a line. It measures how radically we're moving up or down a line. Neat thing about slope is that we always read slopes like a book. So that's going to be left to right. So just like we read a book left to right, we're also going to be reading our slopes and all of the graphs that you work with kind of left to right. And that's going to prove pretty valuable to us. So I'm going to tell a little bit of a story concerning the slope equation and how we find the slope. Very neat. From the equation m, which stands for slope, is equal to, and it's this y2 minus y1 divided by x2 minus x1. Now, these little numbers underneath, they're called subscripts, and subscripts are simply there to let us know that this y is different from this one over here. So the y2 is different than the y1, x2 is different than the x1, but you'll notice that they're stacked vertically on top of each other. The 2's go together, the 1's go together. So this is where the story comes in. Imagine an older brother and a younger brother, older and younger siblings, and if we need to decide which one is older, which one is younger, we're going to go alphabetically. The alphabet goes W, X, Y, Z. X comes first, and then Y comes second. Well, that's exactly like all of the points that we see in our XY chart. And that's because when you started in algebra, you started looking at most likely the number line, which has 0 in the middle, but it's going left to right, and we always called this the x-axis. Now this was the first thing that we showed up with, that's the first thing that we began studying, so x came along first, just like it does in the alphabet, and just like it does in our point columns. After that, once we get from one-dimensional to two-dimensional graphs, we call this second axis the y. It comes along second. It's like it's not as new in your studies. And so what we have here is an older and a younger sibling. You might think y is for younger. But the y-axis, again, represents our vertical. So let's have two sets of siblings. We've got, the XY family set of brothers, and then we have the XY set of brothers over here in the green neighborhood, whereas this one is in the black neighborhood. And those are just because of the colors. The situation is, imagine two sets of friends, each with a younger sibling, going along and they meet up with their friend and decide to have a chicken fight. If you haven't heard of a chicken fight before, a chicken fight is where one person goes up on top of another person's shoulders, and there's two sets of those, and they battle it out back and forth, the people on top, while the people on bottom hold them. So we're going to have a chicken fight. Now, it doesn't make much sense for an older sibling to get on top of a younger sibling's shoulders. They're just little kids. So naturally, our younger siblings take and move up on top of the older sibling's shoulders. So that means that we have a Y on top of an X, and we have another Y on top of the other X. Now, notice siblings stick together, okay? The greens are still green, the Y's and X's are, the black here are still black. And so what happens is they get up on top of the shoulders, so the Y's go on top of the X's, and then they have the battle, and the battle will be represented by a subtraction. You can think of this as stack and subtract. Okay, so we stack these up, again, younger sibling on top of older sibling, and that goes for both cases, and then we subtract, representing the chicken fight, and that, again, is equal to our slope equation. Now, you're saying, but Bill, where are the 2's? Where are the 1's? Again, all of these 2's and 1's represent are different points. We could have just as easily colored them green and black, making this a second point and a first point. Tune into the next video to see how, if we switch these two around, it doesn't really matter.